Hello mga math aaral! Welcome to my 9th step-by-step math video tutorial. In this video, I am going to discuss solving logarithmic equations. In solving logarithmic equation, we must know first the property of logarithmic equations. So if b is greater than 1, then the logarithmic function y equals logarithm of x with base b is increasing for all x. If b is greater than 0 but less than 1, then the logarithmic function y equals logarithm of x with base b is decreasing for all x. This means that logarithm of u with base b is equal to logarithm of v with base b if and only if u is equal to v. We have techniques in solving logarithmic equations, and these are the following. Rewriting the logarithmic equation to exponential form. Using of logarithmic laws and properties. Applying the one-to-one property of logarithmic functions. And using the zero factor property. So let's have examples applying the techniques in solving logarithmic equations. For example 1, we have find the value of x in the following equations. For letter A, we have logarithm of 4x with base 8 equals logarithm of 24 with base 8. In this given, we will use one-to-one property of logarithmic functions. Why? Because we have the same base, which is 8, and there is only one log on this side and another one log on the other side. So whenever we have log equals log and they have the same base, cancel the logarithm. And we have now 4x equals 24. Solving now for x, we need to get rid of 4. Kailangan natin tanggalin yung 4 dito. So, let's divide both sides by 4. So, 4x divided by 4 equals x. And 24 divided by 4 is 6. Thus, the value of x now is equal to 6. So, let us check whether our answer 6 is correct. Just substitute the value of our x, which is 6, in the x in our equation. So, x now became 6. So, logarithm of 4 times 6 with base 8 is equal to logarithm of 24 with base 8. Why? 4 times 6 equals 24. Then we have here, just copy logarithm of 24 with base 8. So as you can see, they are equal. Both on the left side and right side of the equation is logarithm of 24 with base 8. For letter B, we have logarithm of 2x minus 4 with base 3 equals logarithm of x plus 4 with base 3. Again, we are going to use one-to-one property. Why? Because we have here one log on this side and another one log on the other side. And they have the same base, which is 3. So whenever we have log equals log and they have the same base, which is 3, then cancel the logarithm. So we have now 2x minus 4 equals x plus 4. So solving now for x, we need to transpose x here to the other side and negative 4 transpose to the right side. So we have 2x equals 4 plus 4. And 2x minus x is equal to x. And 4 plus 4 is equal to 8. Let's check. Just substitute the value of x, which is 8, on the x of the logarithmic equation. So, I change x into 8. Then, I also change x here into 8. So, 2 times 8 now is equal to 16, minus 4 is equal to 12. Then here, 8 plus 4 is equal to 12. So we have now logarithm of 12 with base 3 equals logarithm of 12 with base 3. So as you can see, they are the same. They are equal. So our answer, which is 8, is correct. For letter C, we have logarithm of 2x minus 1 with base 3 equals 2. As you can see, we have only one log. It is a single logarithm. In solving single logarithm, we use the technique rewriting the logarithmic equation to exponential form. So let us rewrite logarithm of 2x minus 1 with base 3 equals 2 in exponential form. In my previous video, I taught you how to rewrite logarithmic equation into exponential form. So let us recall. The base in the logarithm is also the base in exponential form. And the answer in the logarithmic equation is the exponent in exponential form. And 2x minus 1 is the answer in the exponential form. So we have now 2x minus 1 equals 3 squared. Simplifying 3 squared, we have now 3 times 3 equals 9. So 2x minus 1 equals 9. Solving for x, we need to transpose negative 1 to the right side of the equation. So it will become positive 1. Simplifying 9 plus 1 equals 10. So we have now 2x equals 10. To get rid of 2, we divide both sides by 2. So 2x divided by 2 is equal to x. We canceled out 2. Then 10 divided by 2 is equal to 5. Thus, the value of our x is equal to 5. For letter D, we have logarithm of 16 with base x is equal to 2. Again, as you can see, we have only one log. This is a single logarithm. In solving single logarithm, we use the technique rewriting the logarithmic equation to exponential form. So let us rewrite logarithm of 16 with base x equals 2 in exponential form. So the base of our logarithm is also the base in the exponential form. And the answer of the logarithmic equation is the exponent of our exponential form. And 16 now is the answer in exponential form. So we have x squared equals 16. Solving for x, since this is a square, to get rid of the exponent 2 here, we square root both sides of the equation. So we have now square root of x squared equals square root of 16. So we can now cancel out the radical sign and the exponent. So we have now x. And the square root of 16 is equal to positive or negative 4. So we have two values of x, which is positive 4 and negative 4. So let us check which one of these is the value of our x. So check. Positive 4 is a solution since if we are going to change x into 4, we have now logarithm of 16 with base 4 equals 2 is defined. Why it is defined? Because if this is 4, 4 square is equal to 16. However, negative 4 is not a solution since if we are going to change x into negative 4, it is not defined. Why? Because the base cannot be negative. I repeat, the base cannot be negative. So the only solution is x equals 4. For letter E, we have logarithm of x plus 1 with base 2 plus logarithm of x minus 1 with base 2 equals 3. As you can see, we have 2 logs on this side and no log on the other side. Since 2 log is added, we can use the product law of logarithm to make it a single logarithm. And solving single logarithm, we rewrite it into exponential form. So let's rewrite now logarithm of x plus 1 with base 2 plus logarithm of x minus 1 with base 2 equals 3 into single logarithm. So since it is addition, we use the product law. Multiply x plus 1 and x minus 1. And 1 log is used. So we have x plus 1 times x minus 1. And 1 log is used. Equals 3. Since it is now single logarithm, we can rewrite now into exponential form. The base of the logarithm, which is 2, is also the base in the exponential form. And the answer 3 of the logarithm is the exponent in the exponential form. So we have now the base is 2 and the exponent is 3. Then x plus 1 and x minus 1 is the answer in exponential form. Simplifying 2 cubed, we have now 8. And since this n x plus 1 times x minus 1 is equal to x squared minus 1. Solving now for x, transpose 8 to the left side of the equation. So we have now x squared minus 9 equals 0. Why minus 9? Because if we are going to transpose 8 to the left side, it will become negative 1 minus 8. And negative 1 minus 8 is equal to negative 9. So since this is difference of 2 squares, the factor is x plus 3 and x minus 3. Then equals 0. Equating now x plus 3 and x minus 3, we have x minus 3 equals 0. Solving for x, we need to transpose negative 3 to the right side of the equation. So we have now x equals positive 3. And x plus 3 equals 0 is equal to x equals negative 3. Other way to solve this is x squared equals 8 plus 1. Why 8 plus 1? Because we transpose negative 1 to the right side of the equation. So it becomes positive 1. Simplifying 8 plus 1, it is equal to 9. Then just copy x squared. Solving for x, we need to to get rid of the exponent 2. So, para matanggal yung exponent na 2, let's square both sides. So, square root of x squared equals square root of 9. So, we can now cancel out the exponent 2 and the radical sign. So, we have now x. And square root of 9 is positive negative 3. So, as you can see, we get the same answer. So, to check, 3 is a solution since logarithm of 3 plus 1 with base 2 and logarithm of 3 minus 1 with base 2 is defined. However, negative 3 is not a solution since logarithm of negative 3 plus 1 with base 2 equals logarithm of negative 2 with base 2 is not defined. Let's have the last example. Logarithm of 9x with base 3 minus logarithm of x minus 8 with base 3 equals 4. So as you can see, we have two logs here and no log on the other side. Since two logs is subtracted here, we can use the quotient law of logarithm to make it a single logarithm. Then solving single logarithm, we rewrite it into exponential form. So let's rewrite now logarithm of 9x with base 3 minus logarithm of x minus 8 with base 3 equals 4 into single logarithm. Since it is subtraction, we use the quotient law. Divide 9x and x minus 8 and use single log. So we have now logarithm of 9x over x minus 8 with base 3 equals 4. Since it is now in a single logarithm, in solving single logarithm, we need to rewrite this into exponential form. So, our base here in the log is also the base in the exponential form. And the answer of the logarithm is our exponent in exponential form. And 9x over x minus 8 is the answer in exponential form. So solving for x, we have to simplify first 3 raised to 4. And 3 raised to 4 is equal to 81. And just copy 9x over x minus 8. Solving for x, let's use the cross multiplication. 9x times 1 is 9x. Then, 81 times x minus 8. I cross multiply. So we have now 9x equals 81 times the quantity x minus 8. Simplifying this, we have 81 times x is 81x. 81 times negative 8 is negative 648. Then, we need to transpose 81 to the left side of the equation. So, it becomes negative 81x equals, just copy negative 648. Simplifying this, we have 9x minus 81x is equal to negative 72x. Then, I just copied negative 648. To get rid of negative 72, dapat x lang yung matira, we divide both sides by negative 72. So, negative 72 divided by negative 72 is equal to x. Then, negative 648 divided by negative 72 is equal to 9. Thus, the value of our x is equal to positive 9. Thank you, everyone. Please don't forget to subscribe, share, follow, and like my YouTube channel. Until next time, God bless!